with this system the way it's set up, you've got this compound inequality statement. Whereas we discussed, in the last section, we can break that up. We can make this 0 is less than or equal to x, and we can make it where x is less than or equal to 3. And that can help us set up each individual inequality that we can graph off of. If you're comfortable enough at this point, you may not have to do that. But by splitting this up, when I look at what's involved, I recognize that I've got a couple of vertical lines that I'm going to need to draw in, right? I'm going to have to draw on a vertical line where x is 0. So here's where x is 0. We need a vertical line passing through that point. And then we need a vertical line passing through where x is 3. So we get our lines set up, and we know if x is going to be essentially greater than 0 here, greater than or equal to 0, and if it's going to be less than or equal to 3 here, we're going to be shading in between, right? There's going to be an intersection in between. Now, because so much can be involved when we graph these out, let's save the shading. Okay, we've had practice doing that. Hopefully you'll realize as we do enough of these problems, you can kind of wait till the end to see where all this is going to go together and just highlight what your answer is going to be. All right, if you move to the second part of this system, got another compound inequality. So if I break that up, I've got 0 less than or equal to y, and I've got y is less than or equal to 5 minus x. Kind of limited with my room here, but we'll do the best we can. If I bring that down here, maybe respell some things out, y is going to be greater than or equal to 0, right? If I turn that around, that first statement here. And putting this in more of a slope-intercept form, y is going to be less than or equal to the negative x plus 5. If I graph those out, I know for this first one, we're talking about a horizontal line passing through the y-axis at 0, right? So where y is 0 right there, line passes through. And as far as it being greater than or equal to 0 is concerned, we're shading above, right? So think about how that's going to connect to the overlap for the first part of the system here that we drew out. We've got everything in between for the blue lines. We've got everything above so far for this green line. That means we've narrowed down our region that we're working with as a solution region to right here. So let's go ahead and place this line on the map here. We've got a y-intercept of 5. It's got a slope of -1. So down 1 over 1, down 1 over 1, down 1 over 1, right? I can just continue in that manner if I want to. But this line, once again solid because it's less than or equal to, passes through those points. And if we were going to shade with respect to that line we just drew, we'd be shading below. So where this all comes together right in here. So everything in purple there, if I chose any point in this region, that point would serve as a solution to the system over here. Now moving on to step 2, it says list the vertices for this polygon that's formed. So here's my polygon, right? My little four-sided shape I've got. The vertices would be all those corners. So I've got a corner right here at the origin. I've got a corner right here where the x-coordinate is 3, y-coordinate 0. Had a point of intersection up here between the vertical line and this line that had the slope of -1. That ordered pair at that point would be 3, 2. And then at this point up here, that's my y-intercept. That was what, 0, 5, right? So that's what the list of the vertices of the polygon would look like. And then finally for step 3, we're going to determine the minimum or maximum value for the function if the function is defined like we see here. Okay, the function overall equals that expression 2x plus y. So all that means for us to do is take these points. Okay, let these points represent your x and your y, and let's plug in to what's given here on 3. So for instance, if I start with the origin point, this could be f of 0, 0, at least the way it's defined over here. That would equal, well, replace x and y with 0, you're going to get 0 back, right? So this is going to equal 0. Let's look at the second vertices that we found, or vertex that we found, I should say. Got 3, 0. So x is 3, y is 0. If I'm plugging 3 in for x, well, that's going to be 6, right? Plus y is 0. We're just going to get 6 back. And continue with the other 2 points, doing the same kind of thing. If we look at the point 3, 2, 3 goes in for x, 2 goes in for y. So it'd be 2 times 3, 6, plus 2. So that's going to be 8. And then finally at your point here of 0, 5, we plug in. X is 0, y is 5. So if x is 0, this term's gone, y is 5, we get 5 back. If we're trying to determine the minimum or maximum value for this function, the way it's defined, based on this polygon here that resulted, based on this shaded region that resulted, what we would conclude is that the maximum value is 8, right? Because that's the highest number that we got back. So this is our max right here. Max value of 8. And our minimum value is just going to be the smallest value we got back. So the smallest value we got back, that was 0. So minimum value of 0, maximum value of 8. Okay, so on this system, if we start off with this compound inequality we've got right here, we can break it up like we were talking about in the last one. If I break it up, 3 is less than or equal to x, and x is less than or equal to 3y minus 6. Now if I were to turn this one around and be x is greater than or equal to 3, and we know that's going to be a vertical line passing through the x-axis at 3. And if we were to shade with respect to just that piece, greater than or equal to would take me out this direction. Now, for this second inequality, I might want to solve for y, so it gives me a better form to graph with. If I solve for y, well, let's see, add 6 over, so that'd be x plus 6 less than or equal to 3y. I'm going to go ahead and turn this around so that y is on the left side, mainly for perspective's sake. We're going to divide by 3 as I turn this around, so it's going to be y greater than or equal to. Got to make sure that sign is consistent with how it's opening to that y. If you divide by 3 to this side, that'd be 1/3 x plus 2. If you graph that line, y-intercept is 2. Slope, we're going up 1 over 3. If we draw that line in, I'm going to use the line tool on this one. That's the line we get back. That takes care of that compound inequality statement. Now if we move on to the second part where it's y is less than or equal to 8, and also keep in mind with the line we just drew out here, since it's greater than or equal to, we're now shading above, right? So if you consider where we were shading for this line, which was over here, we're shading above for this one, we've kind of narrowed down our region to right here. Right, if we were going to shade everything in at that point, it'd be everything in between. So y is less than or equal to 8. Moving on to that one. We know that's a horizontal line initially as a boundary line. So let's see here, 2, 3, 4, 5, 6, 7, 8. We draw the horizontal line in. If it's less than or equal to 8, we're shading everything below. So we go below here. Now we know we've kind of narrowed everything down to this region, right? And then finally, we've got one set up for us down here that's already in slope-intercept form, so that's kind of nice. But you'll notice as you graph it, based on the dimensions we have here for this graph, y-intercept is 14. So if the y-intercept is 14, you know, this is 10 up here, 11, 12, 13, 14. It's making it kind of difficult to be real accurate here with how this is all going to intersect, right? But let's think about if we did graph it up here. I'm at this point, I'd go down 1 over 1, right, down 1 over 1, as many times as necessary to draw that line. And that line would ultimately come down this direction, right? It'd come down this direction and it would pass through these two lines. I know that where it passes through those 2 points, on those 2 lines, that's going to be significant because I need those points to answer this second question. So at this stage, we need to think about strategies we've used where we can find the intersection of 2 lines. Anything come to mind? This line's going to pass through down here. It's going to go through the blue line and this red line. Any idea for finding points of intersection? Well, let me review this with you. This is good review. This line I'm trying to draw. If I look at the line itself, it's y equals negative x plus 14, right? I'm going to take that negative x plus 14 since that equals y. I'm going to set up one equation. I'm going to set up another equation because I know this line is going to pass through 2 other lines. If I go back and look at those 2 lines, as this line would travel down and go through the points of intersection, it goes through the blue line first, right? The blue line, which, as just an equation, would be y equals 8, right? So y is 8. That means I could set this first one equal to 8. That would allow me to figure out what x is going to be at that point of intersection. If that makes any kind of sense, this line's traveling down, it's going through the blue line, which we've considered, but it's also going through the red line, right? The red line was represented by this inequality, so as an equation it was y equals 1/3 x plus 2. So since y equals 1/3 x plus 2, I put 1/3 x plus 2 right there. All I'm doing is I'm syncing up the y's. I'm syncing up the y's so I can figure out what x is. So solving for x. Well, over here you got negative x equals, subtract 14, be negative 6, so x is going to be 6, right? So at one point of intersection, x coordinate 6. You know what the y coordinate is? It's going to be 8, right? It's going through that horizontal line where y was 8. So one point of intersection, 6, 8. For this equation, solving for x, might want to multiply everything by 3 first to clear that fraction. If you do that, you've got negative 3x plus 14 times 3 would be 42 equals, multiplying by 3 here clears the fraction, leaving you with just x, plus multiply by 3 here, it's 6. So shuffling some things around, I'm going to add 3x over, put 4x over here, subtract 6 over. That's going to give me 36, right? So x is going to be 9. So over here, a point of intersection, x coordinate would be 9. What's the y coordinate going to be? Remember, you're syncing up the y's up here. So if you know x is 9, I could plug into this expression, it doesn't matter. I should get the same thing back for both. So plugging in, say, over here, would be negative 9 plus 14, point of 9, 5. So I did this because I'd like to know the points of intersection for that line I'm trying to draw. And because I was taken off of the graph, I needed a more precise way to do this. So I'm going to plot these points now, 6, 8, and 9, 5. So let's see, 6, 8. And let's see here, this would be 4, 5, 6, 7, 8, 9, and 5. Looks like that matched up pretty well, didn't it? Line's going to go through there, through those 2 points. And if you think about the shading, it was less than or equal to, so it would be below this line. And we've kind of narrowed everything down to where the shading would occur between all these lines that are drawn. So there's your solution region for this pretty elaborate system. We got the polygon, so let's find the vertices. To find the vertices, just take in all of our corner ordered pairs here. First one I could take right here at this point, that vertex would be 3, 3. This point over here was one of the points of intersection. That was 9, 5. As was this point up here, which was 6, 8. And then finally, we've got one other point we could highlight, this corner. That was at 3, 8. So we've got our vertices. We've got an x and a y at each point, where we can take that x and we can take that y and plug in down here for that function and how it's defined. Now here it's only asking for the minimum value. So as we go through and we plug in for each of these points, whatever the smallest value is we get back, that'll be the minimum value for that function. So if we plug in, say, 3, 3. That would be 2 times 3, 6, minus 3. So 3 back. We plug in 9, 5. Plug in 9, 5, it'd be 2 times 9, 18, minus 5, be 13. 6, 8. Two times 6, 12, minus 8, get 4. And 3, 8. Now let's see here, it'd be 2 times 3, get 6. Minus 8, get negative 2. So the minimum value of this function be the smallest value we got back. That smallest value we got back, negative 2.